Hi everyone, my name is Shubhie Panicker. I'm an engineer on the web platform on Chrome, working on various performance-related efforts.
I'm Nick Jansma. I work at SOASTA, which is now part of Akamai, and I work on Impulse, which is our real user monitoring product.
So over the last year, we've been building a set of new user-centric metrics, working both with the Web Performance Working Group as well as our internal metrics team. And we unveiled some of these at the recent Google I/O. Today's talk is going to focus on the core set of responsiveness metrics and real-world data from the field. We've had an ongoing collaboration with Nick from SOASTA, a major analytics company, both to validate that these metrics capture real-world use cases as well as demonstrate that these metrics are high quality and correlate well with business and conversions.
Yeah, and we've been excited to collaborate on these new browser performance APIs that we're going to be talking about today, where we're measuring responsiveness in the wild. So let's get into it. What is load? What is page load? When we talk about page load time, what are we measuring? And is it really important for our visitors today? You know, we as an industry have really centered around this whole page load metric for a long time. It's important. It's important to measure how long it takes for your visitors to load your pages. It has a direct correlation with conversion rate or how much money you're getting at the end of the day, right? So it's a really important part of the overall page load experience, but it's certainly not the entirety of the experience. Especially with modern apps, visitors to your site are probably spending more time interacting with your site beyond just the page load. And those are definitely all interactions that can lead to bad experiences, lead to frustrations. And those interactions really matter. As an example of this, I'm going to show you a recording I took of loading a popular social network. I had a really good page load experience, but immediately after the page load experience, I was really frustrated because I was trying to interact with the site and I wasn't getting exactly what I wanted. So here's a video. I'm loading this social network. It loads really fast. Look, I mean, it happens in like 3 or 4 seconds. Everything's there. It's fantastic. I start wanting to share my status, and then I want to add an emoticon to my status. And I'm clicking this button, I'm clicking this button, clicking this button. Nothing's really happening. I'm not getting anything back. No feedback. Nothing's actually happening. It's not till 5 or 10 seconds later now where the app actually responded to me. I thought the page was ready. I mean, everything looked visually there, right? Like the whole page was there, all these images were there. But it took a good 10, 15 seconds for the app to be able to respond to me. And this is probably just because some event handler hadn't registered yet. The core framework hadn't fully loaded. Another example of just bad post-page load experiences are things that we do every day, like scrolling. So this is my blog. You know, I load it on the left and on the right. It loads pretty fast, like it feels fast when you're loading it. And when you're scrolling, like on the left, that's how the site scrolls normally. On the right, it's really silky smooth, right? On the right, I've added just a 100 millisecond delay randomly on the page when I'm scrolling, and you're seeing how much jankier it is, how less smooth it is. So even though I had a really good page load experience, I feel like the site on the right is much slower. So what we really want to focus on, you know, page load time does matter. It absolutely does matter, but it's not the only metric that matters, and it doesn't capture the entire user experience. We need to really think about these metrics and what they mean for our visitors. Older events such like DOM content loaded or just the browser's onload event, they don't have as much of an effect in modern apps today. I mean, if any of you guys are building sites with SPA frameworks like Angular or React or something like that, the onload event in the browser really doesn't matter. The framework could load and it could be just a white screen, and that's the onload event. And then your core content loads after that. So you really don't want to focus on these old style just onload metrics, especially in modern apps. But even when the content shows on the screen, like I showed you in the first demo, that doesn't necessarily mean that your app is ready to be interacted with. For example, in that demo, the handlers weren't registered yet, so when I clicked, nothing happened. But other things like the main thread CPU could be busy, and it might not respond to you because it's doing other things. So we want to focus on what matters. Page load is just part of the overall page load, or part of the overall user experience. How your app handles user input matters just as much. Clicking on a link on a button with no reaction can be frustrating. And enough frustrations, and you might lose a visitor for that day or forever. So we really want to move away from the concept that performance is just load time, right? That's not the only important thing anymore. Unfortunately, or fortunately, as an industry, we've really focused on page load time and improving it, and that's great, and we're getting better and better. And our dev tools are focused on page load time, et cetera. But in reality, most of our user interactions, probably not just the page load. I mean, if you think about going to Amazon or Twitter or other social networks, news sites, the loading experience is probably just a small portion of the overall time you're spending in it. I mean, that's the whole point of these modern apps, is to get you there and keep you interacting. Users associate their performance with the overall experience. So even if your page load experience is fantastic, if other interactions beyond that are slow, that's what they're going to remember. The worst performance interactions are what users are going to remember.
So this is a pretty common misconception, trying to put a specific number down on your app's performance. We hear this a lot from developers. I've measured my page load, and my app loads in X seconds. But what does that even mean? Like, which users are seeing that load time? What devices are they on? And what network conditions are they under? In reality, an app's load time has to be seen as a collection of numbers from all those different users. And the only way to represent this properly is as a distribution on a histogram like this. And this applies to all performance metrics. Load is just an example here. So on the x-axis, we have page load times, and the y-axis is the number of times people saw that load. And it's not enough to just focus and make sure that you have an acceptable median time. It's really important to consider the experiences of those 75th percentile and the 90th percentile users that are having these slow, frustrating loads. And so this histogram illustrates the difference between measuring performance in two very different contexts. And these contexts are performance in the lab and performance in the real world. And by lab, we mean tools like dev tools, Lighthouse, web page tests, continuous integration environments. These are really important to get a sense of how your changes are going to behave in the real world, getting deep inside breakdowns, finding and fixing problems. So lab is necessary, but it is not sufficient. The real world is messy. There's just too many permutations of different devices, cache conditions, network configurations, and it's really impossible to simulate all this properly in the lab. So real user measurement helps capture this. It also helps you understand what really matters to users based on their actual behavior. And this may be different from your assumptions. So it's important to map your hypotheses from the lab to the real world. So SOASTA is an analytics company focused on real user measurement. And in fact, later in this talk, Nick will show us data from real user measurement from the field. So these are the key questions that we'd want to answer as part of this talk, and it's pretty much the structure of our talk today. So we'll start out with introducing the set of key metrics. We'll then talk about specific code examples and usage tips for gathering this data in the real world. And then finally, we'll look at this data, how to analyze it, and how to gain insights and find areas to improve. So we'll start with introducing the set of new metrics. So Nick showed us a demo where not being able to interact with an important element was really frustrating for the user. And so to understand why this happens, think of a time when you were in a long line somewhere, at the bank or the grocery store. You're waiting in line, and there's these one or two customers who are confused or irritated, and they hold up everyone else behind them in line. And this is what long tasks do on the browser's main thread. They hold up all the tasks behind them in queue. So from DevTools, we know that there's a lot of different types of work that happens on the browser. Style, layout, script, paint, script, and all of those different types of work happens on the main thread. And it also happens that all the important interactions, like taps, clicks, most animations also need the main thread. So you can start to see how this can be a problem. There's a script, a long script that's running on the main thread, holding it up, and all these interactions are just waiting in queue for that script to finish. And this is the type of thing that manifests as that unpleasant jank and delays in input that we showed you in the demos earlier. So we've been collaborating with Nick, and he's been gathering data for the case studies. And looking at some 3 selected sites, this backs up the fact that there are a lot of long tasks on the web today. For these 3 selected customer sites, the daily average was anywhere from 200,000 long tasks to nearly 600,000 long tasks. And this histogram shows us this long tail of painfully long tasks that are hurting a lot of users on the web today. So long tasks cause a lot of these responsiveness issues, why do long tasks happen? Script is by far the most common cause of long tasks. All the parsing, evaluating of scripts contributes to long tasks, and field data backs up this fact. We'll talk a bit more later in the talk in terms of what these slices actually mean. So we define long tasks as tasks that are longer than 50 milliseconds. And this is based on Rail guidelines. Tasks should be broken up into 50 millisecond chunks so that even if the browser is idle and running a script and a user input came along, the browser has enough time to finish what it's doing and respond to that input. So you might be wondering, what about 60 frames per second? I want all my users to have these smooth 60 FIPS experiences all the time. Why isn't the threshold 60 milliseconds to support that? So the reason is that falling short of smooth 60 FIPS animation is a really small set of responsiveness issues compared to all of the bad user experience from these egregiously long tasks. So we think, focusing on these long tasks is the first step in this quest for 60 FIPS. Now, if you know that you're animating on the main thread, then yes, you have 16 milliseconds to share with the browser. Eventually, in the long run, we hope that browsers are going to move more and more things off of the main thread, but it's going to be a long time before main thread contention is not something to worry about.
So Shubhie talked about these long tasks and how they affect directly user input. How do we measure them? How do we actually understand these in the wild, what our real users are seeing? That's where real user measurement comes in, or RUM. So RUM is the concept of just gathering real users, real devices, real experiences in the wild, capturing it, sending it back to your backend, aggregating it, looking at it, slicing and dicing, and really trying to understand both the good experiences and the bad experiences that your users are seeing. So how can we use RUM to capture these long tasks and other bad interactions? The good thing is there's a lot of performance building blocks out there that we can use. These web performance APIs. You guys have probably heard of them or used them, things like navigation timing or resource timing or user timing. These are all great ways of capturing the user experience, the page load experience, etc. And we can use these APIs and others to also capture experiences beyond just the page load. And we can really get insights into our visitors' happiness by these interactions to see whether they're having a good experience or a bad experience. The way that we're going to do that is with two new browser APIs, or newish browser APIs, Performance Observer and Long Tasks. And then we're actually going to use these to build some new metrics that are more closely aligned with the actual post-page load experience. So the two new APIs are Performance Observer, which is available in a lot of browsers today. Performance Observer helps you understand all these new performance events that are happening within the browser. Long Tasks is exactly what Shubhie was talking about before. We're going to get notified of delays in the interaction on the page. Using these two, we're actually going to build two new metrics. We're going to talk about time to interactive. So that's the concept that we were talking about before. We're measuring not only just when your app loads, but when it's usable, when the user could have had a good experience interacting with your app. And we're also going to talk about input latency. So this is measuring things beyond the page load, just general interactions on your site, when you're clicking, when you're scrolling, etc. We want to make sure your app responds appropriately to user input. And if there are problems, can we actually figure out what caused them? So we're going to start out with Performance Observer. Performance Observer builds on some other core concepts of these browser APIs. The most important, which is the high resolution time. I don't know how many of you have used this. This is performance.now in the browser. It's basically a timestamp. It performs better than date.now for a couple reasons. It's higher resolution, so you get microsecond resolution. And most importantly, it's monotonically non-decreasing, which is just a fancy way of saying that it's not affected by the user's actual clock. So if their clock is changing in the middle of your page load, the high resolution timestamp won't be affected by that. And then we get all these entries from the Performance Observer that tell us these really distinct things that are happening, like resources are being fetched or long tasks are happening within the browser. If you've ever used something like navigation timing or resource timing or user timing before, you've probably heard of the performance timeline, or at least you've used it without knowing what it's called. The performance timeline is basically a buffer of all these performance events that have happened in the browser. So you do something like performance.getEntries by type of resource, and you would get all the resources, all the downloads that happened on the page. It's a synchronous way of getting these resources. You get an array back of everything that happened up until that point, and it's recorded for the entire page load. That's a performance timeline. Performance Observer is essentially the same thing, but in a more performant way of doing that. So it's an observer, meaning you get notified of new events as they happen in real time. You're observing things. This is more efficient. You're not pulling, so you're not trying to always look to see what new entries are there by getting all of them at once. And you can control your own buffering. You can keep track of how many entries you actually want, not all of them within the browser. And the great thing is, again, you're getting immediate notification of new entries as they happen in real time. So these are the two examples of using both. The performance timeline's the old way of doing it. I mean, it's still usable. It's very synchronous. It's a one-liner. Performance observer, very slightly more complex, but not really. You just create a new object. You say, I want to observe resources, and then you get notified. You get callbacks every time a new resource is fetched. So we want to encourage developers to use Performance Observer if possible when you're using these new APIs, so you're not actually affecting the page load performance of what you're monitoring.
So we've said long tasks is the cause of most responsiveness issues, and now there is a first-class web performance API to report when these long tasks happen on your app and give you an indication as to why they might be happening. Now, developers have figured out that the main thread being busy is the most frequent cause of responsiveness issues, and there's all kinds of workarounds that are widely used today. For example, a short 10 millisecond periodic timer and measuring delays between them, or continuously running request animation frames and looking for delays between consecutive refs. Now, these workarounds might give you a clue as to when the main thread is busy, but they're really quite terrible because they come at a high cost of performance overhead, of draining your users' batteries, of not having long idle blocks and being able to use things like request idle callback. And finally, they don't give you any attribution whatsoever. They don't tell you why these long tasks might be happening. So the long task API is a first-class API that addresses all of these issues. And this is kind of what the standard usage looks like. It is pretty standard performance observer usage. You make a performance observer with a callback. You call observe, indicating interest in entry type of long task. And every time the browser's main thread has been busy for more than 50 milliseconds, we queue up these entries, long task entries. And the callback is called asynchronously with the list of entries periodically. So long task API is available in Chrome Stable today, so we encourage you to try it out. It will help you identify responsiveness issues for your app, and it tells you about responsiveness issues for the full page, including child iframes. So this is a demo that we pulled up from our GitHub repo. Some delay here. It's pretty straightforward. All we did was inject arbitrarily long scripts at random times, and you can sort of see what it does to rendering. And all we are doing here is just printing out that performance entry when the callback shows up. And so the fields are basically start time, duration, name, amongst others. So once you have this problem signal from long tasks, the next thing you will want to know is, why is this happening? What can I do, like attribution and actionability? And to understand this, it's important to look at what's under the covers, like what is happening within a long task. So this is an example trace. And what's happening here is that there are actually two different scripts that coalesce and show up within the same long task. And so each script is going to compile and run. And these are fairly long scripts. And so ideally, we should implicate both of them. So in terms of attribution and understanding what to do with long tasks, there are two important pieces that we expose. The first is in the name attribute with what is called minimal frame attribution. And this is basically just kind of pointing in the general direction of what is causing the long task. So this could be self, which is my own frame. It could be a same origin ancestor. It could be a cross origin descendant. And this ability to distinguish between first-party and third-party iframes is a really important piece of attribution that's available from long tasks. The second piece is this attribution field, which is an array of task attribution timing entries. And the idea here is that we want to generate an entry for each type of thing within the long task that we are able to implicate. And then for that, we also want to show you what iframe is responsible. So we have properties like container type, which could be the iframe and container source ID and name to help you identify what iframe it might be on your page. So we are actively working on the V2 API, and the major improvement is addition of this field called the script URL. And this is by far the biggest feature request so far. And the idea being that you can actually implicate what script it is and what line number and so forth.
So now that long task is available in Chrome, we can actually start looking at this data and finding out where it's useful. We already talked about how long tasks can happen during the onload event. While your page is being built, things are happening on the mainframe, and each of these is actually contributing towards the overall page load time. So if you want to measure these long tasks during the onload, turn on the performance observer as early as possible, ideally within the head. If you're collecting this data and you don't want to have your big analytics script in the head as well, you can always hand off the data later. But it's also really important to measure these long tasks during interactions. I mean, that's when your user is interacting with the app. If they're having a bad experience, can we go back in time and look to see what the causes were? So we would suggest doing something like a circular buffer, keeping the last, say, 10 or 20 long tasks. And then if your users have a bad interaction, like it takes a half second, you can actually go look back and see what caused it. There's a difference between like first party and third party long tasks. So first party are you, like your site, your mainframe, the work that you're doing within your framework, et cetera. And third party long tasks, these are the long tasks that are coming from other components that you've added to your website, components in other cross-origin frames like your ads, social widgets, that kind of stuff. Both of these will be causing long tasks on your page. The former you can probably do something about. You can actually make code changes to make it more efficient. For third party, hopefully you can actually hold your third parties accountable. You can actually use this data to say, hey, during my page loads, you're taking 200 milliseconds on average, and that's really affecting my page load experience. So that's the whole point of long tasks, is to hold people accountable. So what can we do with these long tasks? Well, we can actually use this to build another metric. The metric we're going to talk about first is time to interactive. So again, we were talking about how onload is just one indicator of the overall page load experience. It's probably not as relevant today in today's modern apps. A better way to measure it is when could the user actually interact with your app? When could they have a good experience with it if they wanted to interact with it? In other words, when is it usable? And this is really what we mean by time to interactive. When is it usable? As an example here, here's a page load in Chrome DevTools. It's a pretty simple site. The content actually starts appearing on the page on the left arrow when the user sees content. They're starting to see some images pop in. And the onload event happens a little bit later, a couple seconds later. But if you'll notice the middle yellow and purple line, that's the main thread CPU contention. That means that the main thread was busy, and had the user tried to interact with it, even though they saw content on the screen, they probably would have had a bad experience. They might have had a scroll delay, they might have tried to click on something, and the browser could not respond because it was working on other things the whole time. So it's not really until the dip at the very, very end, and this is the difference between 3 and 9 seconds, so 6 seconds later after they saw content was when they could actually interact with the page. And that's what we're trying to find for time to interactive. So how do we measure this? What do we mean by time to interactive? Well, we want to first figure out what the lower bound is. What's the minimal point at which the user thinks they could interact with the website? It doesn't help to have just a white screen, right? The user's not going to try to interact with the white screen. We want to try to figure out, both from the browser or maybe some hints from the site, when all the content was there, and the user might want to try to interact with the site at that point. We're calling this the lower bound, the visually ready point. We get some nice notifications from the browser that can kind of hint towards when content starts appearing on the screen. This is like the DOM content loaded event when scripts start appearing. There's a new paint timing API that's being experimented with in Chrome right now, and that exposes timestamps like first paint and first contentful paint. And so this is, again, when content starts appearing on the screen and the user might start thinking that they can interact with it. The site itself could also give some hints towards what this lower bound is with something like hero images. So hero images are the most important images on your site. They're the ones that you want to be loaded before your user thinks that they can use your app. And similarly, there'd be something like framework ready once your core framework has loaded. So once Angular has loaded and it's registered all of its event handlers. If you have buttons on the screen but nothing's registered to actually do anything with it, the site's not really interactable. So what we want to do is we want to take the latest of all these timestamps, and that's really the lower bound. Time to interactive cannot happen before here. Visually, this is just kind of an example of like one page load where these events would happen. They could happen in any order, right? So the framework is loaded first, we get a paint on the screen, DOM content loaded happens after that, but it's really not until the very end, when images are loaded, that the user would think they could actually do something on the site. Before then, it's just kind of a white page or images are kind of partially loading in. So again, this is our lower bound, and from here, we're gonna try to figure out when the site is interactable after that. So now that we know how to figure out what this lower bound is, how do we measure when could the user first interact with the site and have a good experience? Because I can click on it and have a bad experience. That's not the time to interactive. We want to figure out the point at which if they had done an interaction, they would have had a great experience. The best way to do this is to start from that lower bound and figure out when the next period of idleness is. So a period of idleness could be like a half second or a second, depending on what you want for your site. But basically, you're trying to figure out at what point, if the user started clicking around, would they have had this good experience. Now, the great thing is we can use long tasks to help us figure this out if the browser supports it. Long tasks are a direct indication that the main thread was having problems. It was working on other things. So if we have long tasks, we can make sure that there's a period of idleness of like 500 milliseconds where there were no long tasks. Now, if the browser doesn't support long tasks, what can you do? Well, Shubhie talked about some of the workarounds before, looking at request animation frame to find long frames, doing set timeout polling to figure out if it looks like the main thread's busy doing other things. And yeah, you could fall back on these in older browsers if you need to. It's not as efficient, but it can give you a really good indication that the main thread is busy. So that's what we mean by time interactive. You want to find the lower bound, and then you want to find a period of idleness afterward, where if the user clicked, they had that great experience. We have polyfills both from the Google Chrome team and SOASTA and Boomerang that you're welcome to check out. We would highly encourage you guys to take a look at these and see if it works for your site, or if it doesn't, let us know. We're still experimenting with this, right? It's still kind of the early phases of figuring out whether this makes sense or not. So please give feedback.
The final metric that we'll cover today is called input latency. And this is the metric that indicates when important interactions like taps, clicks, swipes are getting pushed out or delayed. Now, app developers want to know when critical user interactions are delayed, such as clicking on that buy button and getting to the checkout page on Amazon, or clicking on the pin button for Pinterest or Compose and Gmail. These are really important interactions for those apps. Ideally, there would be a first-class API for this, and we're in exploration in the web performance working group in terms of what we might be able to expose there. But it is possible today to get insight into this by comparing the event.timestamp and with the time in the handler, and then connecting this back up with long tasks. So this is a good example of what I'm talking about. Event.timestamp is our best guess at when the event was created. For a tap, it would be when did the user tap the screen. And in the event handler, you can compare the event timestamp with performance.now. And this delta can give you a clue as to how long that event was waiting around on the main thread queue. So in this case, if that delta is more than 100 milliseconds, we log it to analytics. So further, this can be connected back up with your long task timing. So if you have a long task performance observer registered, you can actually go and see what were the long tasks that were going on in this duration. And this is a good insight into what caused the event to be delayed. So we have a sample code linked off of here, which we encourage you to check out.
So now that we've been talking about how great our ideas are, we should actually prove that they work in the real world, right? So we've been doing some case studies with turning on time to interactive and capturing all these long tasks, and we wanted to share some of the data with you. So we've been looking at a couple sites over about a month, 3 different sites. There's a travel site, a gaming site, and a retail site. The first 2 sites are really ad heavy, so you'll see a lot of third-party content from ads. They have social widgets as well. The third site doesn't have any ads, but it has other third-party content, and it's a single-page app. One important thing that I want to talk about when we're going through this data is these sites are not your sites. So what I'm showing here does not necessarily mean you're going to see the same thing at all. And it's really important if you're really interested in this data to go measure this yourself. Every site out there is basically different, right? So we tracked over 18 million long tasks over a month. Again, we're seeing hundreds of thousands of these every single day. And each one of these has the opportunity to affect your users, to make a bad user experience. So these are happening all the time. And they can happen during the page load, they can happen after the page load, they can happen at any point the browser or the user is looking at your site. Here's a distribution of all the long tasks we're seeing as far as duration. So we're seeing anywhere, most of the long tasks we're seeing are happening, within 50 to 100 milliseconds. 50 milliseconds is the lower bound that are reported on, but the median is still around 100 milliseconds. And while 50 to 100 milliseconds may not sound like a lot of time, really each one of those can affect the user experience. Remember that scrolling demo I was showing, that was just 100 milliseconds of work, and you could easily see the difference between a silky smooth and a really janky animation. And each one of these long tasks don't live on their own. They could be, lined up with a bunch of other long tasks. So even though we're seeing the median durations of just 50 to 100 milliseconds, you could have 10 of these in a row that are really affecting the user. The 90th percentile duration is in the 400 milliseconds. You're going to start noticing if you click and the button doesn't respond for half a second. We also saw a really long tail of long tasks taking seconds or more, and this happens more often than not on mobile, and we'll go into some of the mobile data. But each one of these long tasks track a potentially bad user experience. So when are long tasks happening on your site? We were mainly tracking long tasks during the onload experience, either up to the onload event or in SPAs when all the content had loaded. But they can happen at any time. In this case, though, if we split out the long tasks that happen just up through the onload event, we actually see they contribute towards a significant part of the actual page load process. In some cases, we're seeing anywhere from 20% to 48% of the onload time is just based on the CPU time that you're seeing in long tasks. They are having a direct effect not only on your page load time, but on things like time to interactive as well. Remember, time to interactive is when your main CPU is busy. Long tasks are reporting directly on that. So we don't want to focus just on network performance like we have been a lot. We also want to focus on everything that's happening in the CPU, all of the load time that's happening. Long tasks are on the critical path. They will delay your onload. They will delay your time to interactive. And so why is that important? Well, time to interactive has just as an important correlation with the overall conversion rate on your page as page load time does. Conversion is, getting the user to do what you want them to do, like clicking or checking out in a shopping cart or visiting 3 pages on your site because you want to show ads. We're seeing that the first page's time to interactive has a high correlation with overall conversion rate. The more long tasks you're seeing, the less likely the user is going to continue on your site and do what you want them to do. And time to interactive directly correlates into revenue. Like the conversion rate directly correlates into revenue. So you want to really reduce these long tasks. You want to really reduce time to interactive. And even if you're not, even if you don't care about this time to interactive metric, even if you just want to look at long tasks on the page, it has the exact same correlation. The more time your users are spending in long tasks, the busier your CPU is, the less likely overall they're going to convert on your site, the less number of pages they're going to visit. We see that these first impressions really matter. Even just on your first page, the amount of time you're spending in these long tasks will, as it increases, your overall conversion rate is going to decrease. So I talked a little bit about mobile before. This is the 3 sites on desktop, tablet, and mobile. Desktop site on the left, or desktop experiences on the left, mobile on the right. And we can see that the median long task time is dramatically higher on mobile devices. This makes sense, right? Your mobile device is not going to be as powerful as your MacBook Pro, but it's pretty striking to see how much of an effect this actually has. In some cases, we found that mobile devices are seeing 12 times the amount of long tasks. And you've seen this, when you're loading your favorite news site on your phone and you're trying to scroll or you're trying to click, you're getting those delays a lot more, and those delays are frustrating. The great thing about long tasks is they can immediately point to the attribution. They can point out who's causing that. And even amongst devices, like different mobile devices have different characteristics. If we look at a very modern device like a Galaxy S7, we compare it to an older device, a less powerful, less costly device like a Kindle Fire tablet, for example. We see that these older devices are going to see a lot more long task time, in this case about 3 times the amount. And it also changes what's important during the page load process. So a Galaxy S7, as an example, is going to spend more time just loading stuff from the network. It's not going to be as busy on the CPU. While a lower end device like a Kindle Fire or a Kindle tablet or something, you're going to be spending over half of your load time just trying to process all the stuff, trying to run the JavaScript, trying to parse. All the things on the main thread are having a much more important time as part of the overall page load process. So networking is important, it absolutely is, but so are the things that you're doing on the CPU. And it's really important too, like even these lower end devices, on a lot of these sites, you'd be surprised at how often people are browsing with these lower end devices. And finally, we can actually break down long tasks by first party and third party. So the things that you can control, your framework, et cetera, is first party. Third party are other content, like your ads and stuff like that. In fact, I was talking earlier how your site's going to be different. Each of these sites are completely different. The two sites that show ads, the two ones in the middle and on the left, we're seeing a lot of third-party long tasks. That's because of all these ads. I don't think that's too surprising. Ads are slowing your site down, but it helps confirm the data here. Whereas the site that doesn't have any advertising, all of its time is being spent just in its own code, in its own framework. And those will help point to where you should look to help improve your overall page load experience. And finally, via some of the attribution that we saw from long tasks, like the source, the iframe source, or an ID or name, you can actually start bucketing long tasks. You can start actually figuring out the exact culprit, right? So if we look at these sites, we can break them down into ads or social widgets or marketing and analytics scripts, that kind of thing. And they all look different. And that's actually the main point I want to make here. Is your site's going to look different than this data. It's really important to start looking at your own data. So hopefully you can use some of the polyfills that we talked about earlier if you're interested in this and start capturing it. And the great thing is with this kind of data, you can really hold third parties accountable. You can actually look to see which ads are performing better or worse, and hopefully hold the ones that are performing worse accountable or just get rid of them.
All right, so the final segment of our talk. So far we've covered the set of new responsiveness metrics. We showed you code examples and usage tips for measuring these in the real world. And then Nick showed us how to look at this data from the real world and in terms of understanding the impact these metrics have on users and on the business. And this type of analysis is really important to make the case for working on performance. So in this final segment, we'll talk a little bit about high-level guidance for your own performance optimization journey. So first, we said that doing measurements on your own site is really important because every app is different. It's also important to identify your own core set of metrics. The time to interact and the input latency polyfills we provided won't necessarily work out of the box for your apps. So this is a baseline, right? Don't assume it will capture your usable moment. Try it out, customize it, for example, by providing the lower bound that is relevant for your app. It's really hard to come up with really generic metrics that work for everyone, but there is value in making these baseline metrics available and provide a starting point for everyone. And in addition, we also provided the core building blocks like Performance Observer and the Long Task API, and you can use these as building blocks to develop your metrics. So time to interactive is a metric that we recommend for loading performance for interactive apps. We showed how time to interactive correlates really well with conversion. It matters for business, and it's important to drive it down. And to do that, you probably should identify the primary interaction that's relevant for your app, and then figure out the critical JavaScript to make this possible and deliver that JavaScript as soon as possible. Apps that have large monolithic JavaScript bundles are frequently a source of getting their TTIs pushed out. So splitting up JavaScript, careful code splitting goes a long way here. And ideally, we want you to ship less JavaScript. We know it's not always possible, and in those cases, you should be deferring and late loading JavaScript when needed. For example, don't ship the JavaScript for features the users are not going to interact with, pages they haven't expressed interest in. So cracking down on long tasks is the key to addressing responsiveness issues on your apps. And ideally, you would be driving down the volume of these long tasks. And if you really need to prioritize, at least start with the egregiously long tasks and the long tasks that are getting in the way of time to interactive and the long tasks that are pushing out, that are responsible for input latency on critical interactions like the checkout flow. So mobile, as we showed, is especially susceptible to this problem. So don't forget to analyze mobile traffic when you're looking at data on your sites. Scripts are by far the biggest culprit here. So breaking up scripts is really important. And again, this is not just about the initial bundle. It's script parse and eval that happens throughout the user's interaction can cause problems and should be split up. And finally, move heavy-duty work off of the main thread to a worker. If you're doing heavy work like analyzing video or doing image analysis or background text analysis, like this kind of stuff does not belong on the main thread. And again, Nick showed us how third-party content like ads and social widgets are contributing to long tasks significantly. And a single ad or a single social widget can undermine all of your hard performance work in terms of careful code splitting. So it's really important to get insight into these ads and social widgets and how they're impacting time to interactive, input latency, and affecting users and conversion. Long Task API provides enough attribution, and we encourage you to use this to find the damage these third parties are doing on your site. You have all the tools now at your hands, and so please use this to evaluate whether that ad network is worth it, what is the cost to benefit that it's providing, and evaluate different providers. So our work on responsiveness is far from done. We're really just getting started here. The big thing that's coming down the pipeline is Long Task V2 with better script attribution. We're actively exploring the input latency API. And again, long tasks, even though is the cause of most responsiveness issues, it is not the only contributor to responsiveness. There can be other things like scroll latency and animation jank can be caused by the compositor system due to heavy rasterization work or presence of too many layers. So ideally, in the future, we want to have good metrics for all of this. So finally, we want to end with, please check out the APIs and polyfills we provided, file bugs on the GitHub repos. Tell us about your frustrations and success stories. We really want to hear from you. And push on your analytics to adopt these new responsiveness metrics.
So thank you. We ran out of time. We're very happy to take questions over here. You guys are welcome to go to your break. I'm going to tweet out slides after this. Shubhie can as well. So if you want any slides afterwards. So thank you again.